Once again, welcome to this class on Linux basics. This is the ongoing series. The This is the class on Linux and all the programming languages. Uh, Today is our fourth session. We'll be continuing our discussion on the Linux. We started talking about the basics as of the kernel, the file system, and then the shell. Then we went into more details about the commands, and then last week we saw, or in the last lecture, we saw um, the commands, how to do some managing the file access, managing system resources, and managing the general um, disk usage or disk resources. To be specific, we saw the commands like change mode to modify the file permissions. We had the different sections um, in the file permission list. The first one is for the user, the second one is for the group, and then the third one is for everyone else. We saw how to set these access codes. It's actually like a binary number. So it is basically it's a read, write, and execute. So for each of these things, so the maximum that you can allocate a number is 7, which is because read, write, execute, each one is represented by 1 bit. So if all of them are on, that's 111, which stands for decimal number 7. So you can say like 777. That means that it's read, write, execute for all the groups. And then based on where you make the bit as 0, then you can control the access. For example, if you want just you want all the read, write, execute access, so you make yourself 7. And then if the group just wants to read and execute, then you make it as 101, which is 5. And then for all of them, if you just want them to just read, then you make it as 100, which goes to 4. So like that you can control, so 754 or any combination of that you can use to control the access. Then you also we saw the how to change the ownership of a given file from yourself to some other owner, some other user, and then you can also use the change group to change the group permissions itself of the group itself of the given file. This comes in handy because when we look at like various real life situations, a particular file access may be restricted because of certain groups, or particular directory can be accessed only by certain groups, and you may have permission but you don't know like in which group you belong to, and you may have like permissions of multiple groups, and you want to make sure that that particular file corresponds to at least that one group, which will enable you to do more stuff. We also saw like how to manage the system resources. In particular, we saw some of the definitions of the processes. What we call process in Linux, and how Linux assigns process ID for each of the processes. And then we also saw how to report those processes using the ps command or the top command. And then we also saw how to kill a particular process by using the kill, and in which we also saw like the various priorities where the interrupt can be as high as -9, which means that instant kill of that process. We also saw some commands related to the resources, the disk usage. In particular, we saw like du command, the du with various options, and which actually enabled us to get how much disk space is remaining, and then we also like we saw the def command, which is essentially again another way of um, the estimating the usage. Here the def reports on a particular file system, as to the mount point and basically how much memory is remaining. Then we also saw the command free to also understand like how um, how much memory is remaining basically. We also use some other commands. I think we did the to kind of the map analogy where you want to find out like which who is the user. So there's a who command which gives you all the users in the system, or who am I will give you specific to which username that you are using to access the system. So today we will be looking at some more commands. And before we start about today's lecture, I want to assign you some more activities, just like what we did in the last lecture. Today I want you to use man command to find more details on the top. Top is the other command that we studied in the last lecture to get more details on top, and then ph1. Find out and see like what are the options, what are the arguments, how to use it in more detail. Especially the top is very widely used command to see it in the dynamic way as to what is happening with all the processes in the system. And so particular interest is how do you kill within the top, and also how do you exit out of the top. Those kind of things become very useful. Then use the ps command to find all the processes that are running, and use the kill command to stop. Also use stop to find the processes running, and then use the a command. Use at least one command to stop the process from the top command itself. So these are just fun activities that you can do fairly easily. So in today's topic, we will be dealing with more in-depth file system commands. We will specifically talk about grep, fgrep, locate, unique, sort, touch, find. There are other commands like diff and t. I have kind of grouped them here, and we will see why I have grouped these ways. And also like some of the commands that that are also like other commonly used commands like link, how to link a file. The linking is a very easy way of actually um, accessing a file without actually copying the file and incurring like a long time as well as large memory. So let's start. Let's start with these commands. The first command that we will talk about is fgrep or grep. The grep command is mainly used to search a keyword inside a file. So the keyword is specified as a string, and the grep provides a lot of options essentially for doing various things. So here some options are given, which is -I for ignore case, -V for the lines which don't match. So basically it excludes the lines that match, and it gives you only the lines that don't match from a file. And then it's also, you can say like -N, and with following N you can specify some number, so that the command actually displays the lines where it found the match, and then after that the n number of lines which is specified here in that file. So these are like very powerful and useful commands. Typically we try to get use the grep to find a particular keyword, whether that is there in the file, and then once we find it, then we can do all kinds of operations on those keywords, and then we can use it in other programs. Even the string that we specify for matching, that you can specify it as a regular expression. again you can actually go into the man grep or man f grep to get more information about this command itself. There are also like other nifty features like -l, which only shows all the files where the keyword is present. It doesn't output exactly the line itself. So these are all like some nifty things that you can do to gather information. So again, these are all like information getting commands. They themselves don't modify the file or do anything. One of the features that we talked about earlier was this multitasking. So even within a window you can do multitasking, which is essentially we saw this pipe command where we can pipe a command output of a command into another command. So similarly you can use grep command in that fashion. For example, if you want to search multiple keywords and you want to see like which file all the particular keywords are present, so you can actually grep one keyword at a time and then pipe those outputs into the subsequent commands, subsequent grep commands. So it will be like grep A from star.txt, pipe to grep B, pipe to grep C, pipe to grep D. So now the output of this entire command will be one file which contains all A, B, C, and D. So it's again a very useful command, and then you can put it in multiple orders, and we can give you some exercises later on to see how knowledge of that command. The other command that we will talk about is find. The find command is again used to find particular file in a hard drive. So this is like mostly like a file name rather than using really a grep, which is more like a keyword. So using this one you can find files by date, and we can specify also the range of times when it got modified. So here there is an example, find /user/bin, type is f, and then the -a time +100 and -print. So then you can actually like get this particular files using the find command. We can also use find to show the PostScript files in our directory. And then one example is like find star.perl. Here you can see all the commands that end in .perl. So again the syntax follows the general syntax of the any Linux command. Only thing is here the directory is also an argument, which is essentially like find and then the argument and then the options, and then followed by what is the action. For example, here the action is to print that all the files that were found in the example command shown here. So here there's more stuff basically. Like, so if you just don't specify anything, it assumes that it's actually the current directory. So find *perl will give you list all the PL extended files. This is same as you can say think of right now as just ls *perl, that also gives the same output. So the find is also like used when the particular directory is or particular file is embedded in multiple levels of hierarchy, and somewhere below the hierarchy is where this file is. Then you can use find to actually like find the file. The other command is locate. Locate is much faster than the find command, so that is the reason why you choose to use locate instead of find. So again the files are printed with the path if you use the command. So the syntax is just the locate and then the search string. So it finds the file and then it prints the whole path where exactly the file is located for that string. So here is an example again, locate *perl. It gives you like the entire path and then followed by where it is, and then it goes under all the directories. So from the current directory it goes under each hierarchy and then finds if that particular file exists in those hierarchies and then prints all this the entire path. Actually, like I just wanted to restate even the previous one. The find also does exactly the same thing. Instead, even though it doesn't print out the path name, this set of files is not just limited to the current directory. It's actually from current directory onwards, it goes all the way under and then finds that files. So that's the principal difference between the ls command and the find command. Whereas ls only restricts to the particular hierarchy that you give. For example, if you just say ls star perl, it only finds all the perl files in the current directory. If you do ls dot slash blah blah slash star perl, it only goes under one directory below and then looks for the particular files. Whereas find searches across all the entire tree that is under that particular directory and gives you all the matches. So this is a principal distinction. Again, the locate is also the same thing. And then the other command that we will learn is WC. It's not water closet, by the way. So it actually stands for word count. So here the key thing is you can actually determine how many lines are there in a file using this WC command. Even though it's the word, actually it can give you the number of lines, the words, the number of characters, all of them. So again, there are multiple options. -L gives you the lines, and if you just specify WC without any options and then the file name, it gives you all three. It gives you the number of lines as the first column, number of words as the second column, and number of characters as the third column. Then you can specifically go ahead and ask WC -L file name, that gives you the number of lines. WC -W, the file name, gives you the number of words. Again, the words means the 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 non-white space characters, group of characters separated by a white space character or a new line. So those are the words. That's the definition of word. And so that collection will be treated as a word, and then it will just output the number of words. And then the WC -C, the file name, will give you the number of characters. Here the number of characters typically is the non-white space characters. So all the white space characters are not reported. So here are some examples. So here is a default one, WC test color.v. It gives you the 5 lines, 8 characters, 8 words, 93 characters. And then here you can also see like somebody is piping the ls command into WC -L. So then it gives you since it is ls, basically like it gives you how many lines are there in this output of the ls command. So again, as I said, like when you use the pipe, the command's output gets piped to the particular command. So in this one, you can think that basically there are 68 files in that in this directory. Even though like the regular ls actually gives the files, multiple files in the same line, when you pipe the ls to the WC -L, it gives each file as one line. So that's why like you get like the actual number of files of 68. So the next command that we will learn is sort. A sort command is used to sort the files in the alphabetical order. So a sort file name, sort and then the file name, just takes all the lines and basically like sees which line to be coming first in an alphabetical order, and then it presents that way. For example, in this case, Linux 1.x, we have C, C++, .NET, Eclipse, Java. So you can see that actually like it's C, D, E, F, G, like it just goes in the alphabetical order and reports this file. So inside the content may be in any other order, but when you do a sort, it sorts it immediately into alphabetical order. So again, this is another useful command if you are collecting some data and then the data is all in some form and you want to present it in a much better form. So you can use this command to present it in an alphabetical order. So now let's move on. This command unique. This command prints out the file, removing all the duplicate adjacent lines. So again, you can say unique file name. It gives you all the lines that are appearing only once, essentially. And then there are options to it. So for example, unique minus u, the file name, dash dash unique prints all the unique lines. And then if you say like repeat it with dash d option, it only prints out the what are the duplicated lines. So again, this command is used in many ways. Basically, it is very useful. If you have a particular file name which you copied from multiple sources and you don't know whether something is repeated many times, one way to find out is just use this unique command. You can also say like dash c file name, which gives you the number of times a particular line has occurred. So for the unique lines it prints out 1, and then for the other lines it prints out how many other times that particular line has been occurring inside that file. So let's look at some examples here. We create the test, we create this one. You can see that actually Dravid is repeated. Sachin is actually repeated but in a different location, and Ganguly is repeated twice. Kumble is only once. So if you just give like just unique text, now it gives you the Sachin twice, but Dravid and Ganguly are reported only once, so that they are unique. So one way to eliminate these kind of situation is to use the sort. So when you do a sort, the Sachin and Sachin, whichever position actually like they just gang together. So in this case it will be Dravid, Kumble, or Dravid, Ganguly, Kumble, and then Sachin, Sachin. So now if you say like sort the text and then pass that to the unique command, then you get really just the unique values, because the two Sachins are coming now together and that gets eliminated by unique. And then you can say like unique minus u the text, then it gives you like Sachin Sachin and Kumble. So this is the this show illustrate how the unique command is getting used. Actually this is an error probably. The unique minus u is actually it only prints out the unique lines. In this case, like if you have sorted this way, then it will print out the actually like because the text is still this one, so that's why Sachin is printed twice, because it thinks it's still they are unique because they appear in different lines. The entire Dravid is gone and then the Ganguly is gone because they are repeated. So that's why the unique minus u and then the file name gives 2 Sachins and 1 Kumble. So now let's go to the next one, which is touch. Touch is a way to create empty file. So when you say like touch and then the file name, an empty file with that file name will be created. It will have a size of 0 bytes if it does not exist. If that particular file exists, then it updates the timestamp so that it, it appears as if like that file was updated just recently. Okay. So again, this is useful in the sense that some particular commands that you may work on will not run if the file is not updated to the latest timestamps, or you may have a requirement that this particular file needs to be updated much later than another particular file. So but that file may be created later than the file that you want to access. So in that sense, you can just do a touch and then the file name, which updates the timestamp, and then you can do whatever processing that you want to. So here, as an example, we want to change the access time of file 6 to 10:10 in May. So here we can actually give a particular date, and then we can say like touch. So touch minus b 2nd May, and then followed by the time, and then it will change the timestamp to that particular time. So you can use an ls minus l to verify whether the timestamp change has happened or not. So another way to do it is dash t, touch dash t. The touch dash t takes an expression which is month followed by day followed by hour followed by minutes. So it's shown here like month, day, hour, minute. Once you specify this format, it actually updates the timestamp to that particular format, that particular time. So that that's another way to change either dash t with the date inside the quotation, or just specify dash t and then as a string you can just specify the whole date, and then it updates to that one. Typically we don't use with any options. You can just say touch and then the file name, then it puts the latest timestamp into that one. So it just gets the timestamp from the date command, and then it puts that particular date for that file, so that it appears as if it is got modified. And then if it is not there, then as I said, it produces a file with 0 bytes. So here are again some more examples. So when we say like touch and then we see what is the disk usage for that particular file, it reports 0 bytes. And if you do an ls minus l, it will still report the 0 bytes as the latest timestamp. And then we say okay, now we want to change the timestamp, and then we provide this timestamp, and then when we say like ls minus l text, we see an older timestamp. So again, you can advance the date or move it forward. You cannot move it forward more than the system date itself. So that's another thing that you want to make sure. So here it's also like we use the dash t option to change the date on that particular file, and it changes consistently. So as I mentioned earlier, there are few commands to actually alter the programming behavior or managing the system resources. One thing that we saw was the pipe command. Then we also saw like how the processes can be called in. The other command is what is called the T. The T command actually sends an output of a program, or in our case it's a process, output of a process to 2 different directions at the same time. So you can specify T and then file name with options, and then it can actually send it to 2 different locations. So what are the 2 locations? Here one is it stores into the particular file. So here we have an example, ls minus l type t file name file 2. So now let's see how this works. So ls minus l generates an output which is the list of all the files with all the details inside the directory, and then that is actually piped to t and then file 2. So when it is piped, actually it is actually going to the output file. In our case, it's the terminal where it displays what is the output of that ls minus l command. But we say that also do a t to file 2. That means that it actually writes out the same information into file 2 as well. And dash t minus a is an option to append to a particular file, the same as the double arrow. When we say double arrow, it only does just that portion of it, that's writing the file, writing into file, whereas a t will write into the file and also output into the terminal. Let's see an example. So in this example, we initially store the output of ls minus l using a greater than arrow into list 1. Now the second command is interesting, where we did the same ls minus l, but now we pipe to t list 2. So now let's see what is the output. So when you do the ls minus l, it's actually there are all these 4 zero size files, file 1, file 2, file 3, file 4, and then there is some finite amount of size which is list 1. So now what will happen when we do the list 2? So one thing is to notice is that when we specify this ls minus l pipe to tl list 2, it displays the output of the ls command in the terminal, which is, you can see there are 4 zero size files, and then the list 1 which we created earlier, which is ls minus l sent to the list 1. But now you see that basically it produces this output at the output terminal, but also now it writes this information into another file called list 2, and that list 2 is not shown here because at the time of keying, basically there are 2 parallel processes. So the list 2 was still getting updated, so it doesn't even know that that particular file existed at that point. So the ls minus l produces the normal output. Now the next command is the t with dash a, which means that we want to append the list 2 with the same ls minus l command. So now if you look at it, now the list 2 command, list 2 is shown, and pretty much you can see that actually they have similar type of number of bytes. So again you can see that actually there's some more information that gets written into the list 2, but in general you can now see how the thing works. Again, in this case, the T is still, it works as 2 processes, and those processes are executed independently. So it still doesn't know the existence of this particular file list 2. So once we finish the execution, that's when it gets written into the directory, and then that's when we know that actually okay, this file exists, and so the subsequent commands will start using the file. Okay, so now we will go into a few more commands which are quite important because these are the commands that you will use more often in the current course, as well as when you go out in the real world. You will be using all these commands in much more details. So the next command is CMP. CMP stands for compare. This actually compares 2 files and reports if they are identical, and it reports the position of the first character. the program itself generates a 0 output if they are identical, otherwise it produces a 1 output and then it shows the difference. So the syntax is just CMP file 1 file 2. That's it. So here we give a CMP ex1.x and ex2.x. Here it says essentially like it differs in byte 1 and that is line 1. So after it executes this, it stops and it comes back to the shell. So again, CMP is another useful tool to understand how to what are the differences between two files, and then how to bridge those differences as well. So we already saw the find command. Actually, this slide should have gone with the earlier one. And we know that actually it's basically defined the path selection criteria, essentially the path followed by selection criteria. So you can say find dot, which means that start from the current directory, and then the selection criteria will be the minus name is top.v. So it looks at looks for the top.v, the current directory, and all the way under. And then you can also say like find dot and then slash type D, which is then the type which is the directory, and then it finds all the directories under that particular under your current directory. And anything like dot star, as we know, the hidden files start with dot in the as a beginning. So again, like when you do the find dot with type F and name is dot star, then it finds all the hidden files as well. Again, this all should be followed by also the second item, which is what to do with this data. So like dash print, things like that. So here in the home dir2 exam.txt is what we want to find, and then it gives you that basically, and then it also gives you all the things under the home dir2, which is dir2, dir3, dir4, dir5, 6, 7, all the things are printed out. So now we come to another important command called diff. Actually, diff is used to get the differences between two files. So it compares the two files and reports what are the differences. So there's a simple diff which is which basically compares the two files and then displays on a running. Actually, it shows a running display of what are the differences, and it tags one file by less than and then the other file by greater than to distinguish the difference between like those two, and then it reports like all the lines which are different. Then there are specialized commands, vimdiff file name 1 file name 2 or sdiff file name 1 file name 2. These commands display the files side by side. As a part of this vimdiff, you can also have a tkdiff, which is using the tickle tk interface to create a UI so that you can compare those two files. And the good thing about all these commands are you can display the differences, and then you can merge the differences. You can merge file A's differences to file B, or file B's differences to file A, in whichever way that you want to go to. And then you can do several other things. Essentially, you can even make both the files exactly the same. So basically the differences between A and B, whatever is in A will go into B and whatever is in B will go into A, things like that. So again this is another powerful command. I want you to use this. In real life the diff command is often used to find differences between two files, either two scripts to run a particular tool or things like that. And then it also helps us to find what we changed which caused certain issues. So you can compare the current version with the previous version to see like what changed, and so then you can take some corrective actions against it. Or you can go the other way, like if you see that actually okay they are different, then you can say like okay throw away my old file and then or throw away my new file and I'll use the old file. Things like that also you will do. So it's a very helpful command, and you'll be using it a lot in the real world. Vim diff, again it shows side by side and uses the editor called VI. We will talk about this in the programming context in the next week. But there are these editors to edit files. One such editor is Vim, or it's a visual editor VI. There are other editors like Emacs is another one. Probably you must have heard about that. VI is very common because it has a very fairly easy to understand interface. So people like that a lot. Couple of other things that I wanted to highlight are, one is the use of tab, that you can use tab to complete a particular command or complete a particular file in the particular given file. So this again is you don't have to type everything excruciatingly painful way. You can stop at some point and then let the tool continue and complete that particular work. So that's also provided. I also wanted to briefly touch upon one additional command, which is ln or link. So imagine you have a file system and you have a file which runs into like a couple of gigabytes or even more. These days, like 50, 100 gigabytes is nothing. And then now you have another directory where a particular program that you want to run, and which also needs this file as one of the inputs. Now one way to do it is you can just copy that file over to the new location, and then this particular program will access that file and do whatever it wants, and then basically it um, it finishes essentially. Instead of that, we can also think of another way where we don't copy the whole file into the new location, which can lead to actually like two things. One is if you copy the file over to the new location, since it is running into like multiple gigabytes, probably it will slow the whole system down, and it will take a long time for the particular file to be copied. The second thing that it has is basically it eats up those memory. Like now unnecessarily you are having like two copies of the same information, and as a result you are just occupying the disk space with that, and as a result some other important programs will not get a chance to work because you are blocking the system with your um, um, your jobs. So a better way is to actually link a particular file. Linking a file means essentially you are creating a pointer to that file in that directory, so that the program that wants to access can chase that pointer and then go back to that particular file. The links can be created in two ways. One is called the hard link, and then the other one is called the soft link or the symbolic link. So let's look at what a hard link is. A hard link is when we specify the command followed by the target file name and then the link name. So here both of them are arguments, and the first argument is what the link that you want to create, and then the second one is what sorry, first one is the file name which you want to create a link for, and then the second one is the name of the link that you want to create. So if you specify ln target file name link name, then it creates a hard link to target file name or link name. So why is it called a hard link? So the hard link is because even though if you remove the original program, the program content still lives under um, this target name or essentially the link name. So if you want to delete a file, it's not just enough to delete that particular file name from the file system. You also need to delete all the hard link references to that file. So because otherwise, like it still keeps the data for the link to work, and it will make it work. The other command is ln -f and then target name and then the link name. This creates a soft link or a symbolic link to the particular file name or the target name that you want to associate to. So here if you have a soft link and then if you're saying like okay delete my original file, then when next time when you run the program it generates an error saying that hey that particular file is not found even though like it exists in the symbolic link. So you need to pretty much chase through the symbolic link, find out where exactly it is and then add that particular file. But the key thing is again the symbolic link you want the program to fail if it doesn't find the file. So again, so that is the reason why a symbolic link is preferred over a hard link in most of the programs. So in this lecture we covered a number of topics, all very important and very useful commands like grep, fgrep, locate, unique, sort, touch, diff, t, and also like the link commands. So I think this should give you a good flavor of the entire Linux system. We will be starting to talk about the Linux networking in the next session. But with this actually like I mean we cover all the basics of Linux. So and we'll also have some more assignments that will be coming your way. But we will also do a recap of this lecture in the next one when we start the Linux networking. So again thanks a lot, thank you very much and good luck.